We've now reached that point in this topic's coverage where we're going to ask ourselves, why do we really care about knowing what a soil's strength is? Specifically, why do we care that we know what a soil's bearing capacity is? The answer is because it allows us to predict what we can put on top of that specific soil sample, or that type of soil we've sampled. Can you see how important this is? If we know that a soil can support a specific load, then we also know that we cannot build a structure on it that weighs more than that soil's bearing capacity. If you remember from when you performed a Proctor density test in your first year of schooling here, you'll recall that it takes at least 24 hours to dry the samples and analyze the results. That is also assuming that you don't have to redo the test. One of the frustrating things about the Proctor test is that sometimes, if you remember, the curve does not actually come down. Instead, it goes up, which means that you have to redo that test. As you can imagine, the Proctor density test is not exactly real time, and, as such, does not lend itself well to on-site inspection and quality control. Instead, another method is used for on-site inspections. On-site inspections are performed according to standard ASTM D as in David 6938, which regulates the testing of density and water contents in soils by way of nuclear methods. These portable devices you see on the screen are commonly referred to as nukes and are used to perform these on-site compaction inspections. They have the ability to determine the water content and density of a soil sample in real time. If you refer to the video in the Wikipedia page I linked for you in your course notes, you will see how this test is performed in general terms. First, a hole is hammered by way of a pin. Then, the nuclear gauge is placed over that hole so that the radiation source may radiate to the ground. Lastly, a reader at the end of the gauge reads the photons emitted from the source. Based on these photon readings, the density and water content of the soil sample can be determined in real time. Now, some food for your thought. Since this is so much faster and effective, why isn't this method used exclusively to replace the Proctor density test?